Hello again. Good to be on stage again. I had to wake up pretty early. That was okay after the party. Just a quick show of hands. Who was here for my talk yesterday? Okay, most people. Okay, good. So this is the talk I was originally going to give at DevFest, and then they're like, "Can you give both?" And so I was like, "Okay, can't say no to that." So this is a more advanced, kind of the next stage of what we talked about yesterday, and it deep dives into metrics and tracing. So it's all about metrics and tracing for your microservices, right? So you remember this, and you remember this, and you remember this. Because microservices, they can get really, really hairy really quickly. So one thing that I think is very critical for microservices is distributed metrics and distributed tracing. And so the reason why is when you have a graph that looks something like this, it becomes very hard to know who to blame. And, we always want to blame people when things go down, and you don't want to blame yourself, right? So if you're in the middle of the stack, do you blame yourself? Do you blame the person in front of you or behind you? Who's to blame? No, I'm just kidding. We don't want to blame people. We want to just solve problems, right? And if you don't have the right tooling, it becomes really hard to even understand what's going on in the stack. So what microservices do is they kind of add complexity to your system. They add network and infrastructure complexity, right? In the past, you had your app, you deploy it, you're done. Now you had to have Kubernetes and Istio and all this kind of stuff to even get your stuff to work, right? Why do we do that? The reason why we do that is they can remove code complexity from your system. So what do I mean by this? When you have very simple code and you have it deployed in a microservices fashion, you can refactor that whole microservice in a week, right? It's very possible. If you have a giant monolith, trying to refactor a small part of it might break everything else, right? So it removes the code complexity, but it adds a ton of infrastructure and network complexity to your application. But then a really nice thing is that infrastructure can be automated, while code can't yet, until we get machine learning that writes code for us, and then we can all retire. Until that day, we had to write code by hand, right? And so infrastructure, especially in the age of the cloud, can be automated very easily with APIs and tools like that, right? So what we can do is basically automate away a lot of this complexity by using the right tools. So again, let's use tools to simplify the infrastructure and network complexity, right? So we talked about Kubernetes yesterday and Docker and things like that. We talked about Istio. But let's talk about distributed tracing a little bit in more depth, right? So in yesterday's talk, I kind of had 3 services. They talked to each other, and then they got the response back. We don't really know as service A what service B is doing, right? All we know is that service B is taking 100 milliseconds to respond. That's all we know as service A. As service B, we know that service C is taking 90 milliseconds to respond, and we're only adding 10 milliseconds of overhead, right? But service A doesn't know that. It just thinks service B is slow. And it gets really complicated for any sort of non-trivial application, right? A, B, C, very trivial. But let's look at something like even this. Even this is trivial. But you can see right here that our analytics front end gets a single request, right? That might fan out to 3 different microservices, auth, billing, and reporting. And then all of those services use a common database layer, let's say Spanner, for example, and then that goes to a storage layer, right? So Spanner sees 3 different requests coming in. It has no idea that these requests are anyway related, right? It was one request to the analytics front-end server that caused these 3 to be created. But again, Spanner just sees 3 separate requests. It has no idea that these are correlated. And so you lose a lot of information for this, right? Maybe you had a really weird request coming in from some new person on the team who wrote a new query to the analytics front end, and is doing some weird stuff that's causing auth and billing to have a race condition, and that's being sent to Spanner, and it's like just doing some weird stuff, and that's why it's breaking, right? But if you just have the context of auth and billing doing its separate thing, you would never tie that to the original query coming in that's actually causing issues in your system, right? So tying all of these different spans together becomes very difficult in any distributed system, right? It's not just as trivial as A, B, C. It's like A to B, which also talk to D, and sometimes E, and it's like very complicated, right? So one of the tools we use to look at these kind of spans is something called a waterfall chart. How many people have opened up Chrome DevTools and seen something like this, right? I think most people have. It's very powerful and it lets us kind of visualize what's going on. And everyone kind of does it. So this is Zipkin. It's kind of one of the open source distributed tracing tools. And you can see here, like this request right here took X amount of time. MySQL, it waited for that MySQL database to finish, then it ran another query, and then it did a bunch of stuff in parallel. So you can see, what is serial, what is parallel very easily, right? And every tool looks something like this. This is a Google Cloud's Stackdriver trace, which Mete showed off in the last talk. Again, looks almost the same because it's a pretty good format. You can see here, it's getting something from Spanner, so database call, and then it's doing a bunch of stuff in parallel, right? So one thing we can see from this is that it doesn't matter how fast get top picks is, because get articles is slower, right? So we can optimize get top picks to have half the time, but we still have to wait for this get articles to finish, right? So it's a kind of a waste of time to optimize that in a certain way, right? Because who really cares? We were waiting for the full thing to finish. So this is a really good way of identifying where in your code and where in your system are the low-hanging fruits for you to kind of optimize first, right? And so you waste a lot less time finding where your problems are with a chart like this. So what are the criteria for doing distributed tracing, right? So first, you have to create trace IDs and tags for the incoming requests. So every single incoming request has to have a way of identifying itself, right? Now, every service needs to report these traces to a collector. As it goes down your 20 microservices, every one of these services actually has to report it to that centralized collector. Every service needs to forward these headers downstream. This is critical. If any service in this, this big waterfall forgets to do this, every single service underneath it loses complete context for what happened, right? So if anyone forgets in your company or your stack or whatever to forward these headers downstream, you lose all context. And then, of course, you need to be able to query and search these traces. Okay, so distributed stats are very similar. Let's look at this. This is like a default Stackdriver dashboard. No one can read anything on that slide, which is fine. It's showing you things like CPU usage, memory usage, disk I/O, things like that, right? So I call these like infrastructure level statistics. They're pretty useful. You can infer a lot of things about what your application is doing, looking at CPU and disk I/O and things like that. But they're really not the stats you care about, right? What you care about is things like number of requests per second, number of 500s per second, average latency in your request response rate. These kind of things are what you actually, are the business metrics that you actually care about. And so a lot of people use, CPU, memory, disk I/O, things like that as a proxy for the metrics you actually care about. So what you really want to do is instrument your application to give you those real those real business critical metrics, right? And you want to be able to understand, again, in a distributed system, the flow of metrics from one to another, and what's causing what to go up or down or whatever, right? So again, you need to be able to collect these stats that are meaningful and report them to that centralized collector, and then be able to query and search these stats again. So very similar problems to distributed tracing. So here's some really good news. There are a ton of vendors who will gladly sell you a solution to solve these problems, all right? Including folks like Google with our Stackdriver products, other clouds, open source folks. There's tons of solutions. And so now you're thinking, oh man, if I pick the wrong one, I'm screwed, right? How do I know which solution is going to work best for me? How do I know which solution is going to best work tomorrow for me? If my company grows, I can no longer use XYZ, or I want different features. Kind of annoying, right? So I want to talk about two projects, OpenCensus and Istio. We talked a lot about Istio yesterday. Basically, it's a service mesh that will automatically do a bunch of stuff for you in your network. But OpenCensus is another tool. We have a tool internally at Google called Census. So we came up with a really great name, OpenCensus. It's an open source reimplementation, just like Kubernetes was, of Borg. And it's a way to collect distributed stats and metrics and export them to a lot of these different platforms automatically, right? So we all know, there's 14 competing standards and it's ridiculous. We gotta simplify it, so now there's 15 competing standards. That's really not what OpenCensus and Istio try to do. OpenCensus is trying to support whatever exists already in the ecosystem, right? And it's trying to do it in a vendor-neutral way. So the whole point is, if you want to use Stackdriver today and you want to move to Jaeger and then you want to move to Zipkin, that's fine. You don't want to re-implement everything and re-change all of your code, right? You just use OpenCensus and it'll support all of these out of the box. And so it's all about code portability and letting you choose the right tool for the job, right? So the whole point of these two things is they kind of provide great tracing and stats for operations folks while getting out of the way of developers. You don't want to force your developers to write a bunch of code that's specific for tracing and stats that they don't really care about, and then redo it and rip it out to switch providers and things like that, right? So you want to kind of get out of the way of developers, let them do their job while giving operations the insight they need. Okay, so yesterday I talked all about Istio. We talked about all these things, or most of these things. We didn't talk about fault injection or circuit breaking, but it has all these features. I'm not going to talk about any of these. Again, if you want to learn more, you can go and see either the talk from yesterday that was on YouTube, or just go to this short link to one of the videos. All I want to talk about is the stats and the metrics for Istio, right? So how Istio works is it sits in front of your code, and it intercepts all network requests, right? So if you have service A talking to service B, C, and then back, this will all go through the Istio proxy. And then what Istio will do is it'll take all the metrics and then automatically forward them to a collector on your behalf, right? So you don't have to write a single line of code to do this. But there is an issue with this. And the issue is it only sees the network requests going in and out. It has absolutely no idea what's happening inside of your code. And that's where OpenCensus comes in, right? So yes, request out, request in, that's great. HTTP or gRPC or whatever you're calling your microservices with, that's great that you have that. But what's actually happening inside of your code, right? What is this request might cause a function to, recurse forever or something like that, right? And if you just have the network level statistics, you can't really look inside and see why or what is changing inside of your code. So OpenCensus lets you instrument the same kind of things inside of your code. So now you can look at your functions that are running, the sub-functions, whatever, and again, sending it to that same collector. Okay, so we're going to go through a quick demo, and then we will have time for questions. So again, all the code is open source right here on my GitHub, but let's take a look. So we're going to go back here. If you were here yesterday, you know what this code looks like, but I'm going to go through it just for folks who weren't in the talk. So I basically have a microservice that I can chain together in an infinite fashion. So I have 3 copies of this running. Let's look at what it does first. So basically, it will talk to a backend. In this case, it'll get it from an environment variable. And it'll basically ping that backend and then wrap it with some time information, right? So start time and end time. So let's deploy this into my Kubernetes cluster. And then, okay. So what I'm going to do here is kind of go to where we left off yesterday in terms of the demo. So just for folks who weren't there yesterday, I'm going to go through very quickly what we're doing with Istio. So here, let me go to and show you what it looks like. Okay. So here we, this is our application that we showed off yesterday. The front end here is talking to the middleware is talking to the back end, and the back end is talking to worldclockapi.com and getting this response, right? And you can see here, the front end took 4.8 seconds because it's wrapping around the middleware, which is taking 4.3. And the backend takes the largest amount of time, 3.9, because it has to go up to this external endpoint. So what Istio is doing is it's adding a little proxy to each of one of these containers, or sorry, these pods. So the pod is 2 containers, even though we only defined 1. We can look at that really quickly. Deployments. So here, we only have 1 container defined in our Kubernetes YAML, and of course our environment variables. So this is pretty straightforward stuff. What Istio is doing is adding itself automatically to our pod, so it can proxy all those network requests, right? So if we go to our code, you might be curious on why we're doing this like headers thing. And so I said I would talk more about this yesterday, right? So what we're doing is actually forwarding these trace headers along, right? So these are the B3 trace headers that are used by Zipkin and basically the whole industry. And so Istio will generate these headers coming in, but it's our responsibility to forward it along, right? And again, if any application in this chain forgets this, we lose all context for everything downstream, right? So this works really well. And if I go here to Jaeger, let's go and refresh this a few times to create some traces. You can see here, again, we saw this yesterday, the Istio Ingress Gateway talks to the front end, talks to the middleware, talks to the back end. But what is going on inside of these services? I have absolutely no idea, right? It's like a black box. It's just how much time the whole service takes to respond. So that's kind of not super useful because I don't know like what is actually going on inside. Obviously, I can tell that backend takes a long amount of time, but that's all I can tell. I can't tell why. Of course, and again, we showed this off yesterday. If we go to Grafana, we can see cool dashboards that are pre-created for us. What is the port? It is, I always forget the port names. 3000, of course, something simple. So go to port 3000, open up Grafana. And again, I'm just running these locally in my cluster. Obviously, in real life, you would use a more highly available monitoring system, and not just running in memory. So again, out of the box with Istio, you get a lot of the network level statistics. Success rate, let's say non-500 responses. Request size, latency, all this kind of stuff. You can build your own dashboards. All this data is sent to Prometheus by default, and in Prometheus you can run your own queries and run your own data and build these dashboards. So speaking of Prometheus, let's go here. So you can see here a bunch of these metrics, and so these are all Kubernetes metrics. But of course, if you go down on these Envoy inbound cluster, so you can basically write your own queries. If you were to see the Prometheus talk yesterday, went way more detail that I will into like how you actually use Prometheus. But you get all of these really nice metrics, so all these Istio metrics and things like that. See what's there. So you can run whatever query you want and create your own dashboards if you don't like the built-in dashboards that Grafana comes with, or so the Istio version of Grafana comes with. So that's all well and good. We saw this all yesterday. You get these, network level statistics. So what do you do now that you want more detailed statistics, right? So that's where OpenCensus comes in. So the first thing I want to do is get rid of this. I don't want to do this anymore, right? So let's see how OpenCensus can help. Nope. All right. Okay. So the code looks literally exactly the same, except we're no longer doing the header thing. Interesting. Okay. What happened? All I did was I added the OpenCensus library, and then said tracing.start. And so for Node.js, what this will do is it'll actually patch into the HTTP framework and then add tracing in and out automatically, right? So when it sees an incoming request, it'll actually understand that context of what's going on, and then any outgoing request from that context, right? So right here, so anything that's coming in here will automatically get these trace IDs appended without you having to write a single line of code. So of course, this is how Node.js works. In Go, it's a little bit different. It's the other language I've used. In Go, you get a context object, and you have to pass that context around. Go people tell me that's very normal. I don't know. So, in fact, this code was originally written in Go, and I can actually show you that. It's really fun. No, it's not. Let me show you. I just like doing this because everyone hates JavaScript, but come on. I can't find my code. Damn. Oh, here it is. Okay, so this is the code for Go. That one line became this whole like ridiculous like I don't even know. Okay, anyway, Go is very verbose. Anyway, but again, here it looks exactly the same. In fact, we removed that need for the headers. So let's actually deploy this and see what happens. What is the thing? There we go. Okay, so what we're going to do is update our deployments that are running in Kubernetes with this new code that's using OpenCensus. So again, all we had to do was kind of add this B3 propagation format, and that's it, right? Okay, so again, if we go to our code and hit refresh, it looks literally exactly the same. Oh, it's rolling out. Let's see what happened. Oh, okay. Obviously, when you do a real deployment, you don't want to just, update stuff sillily. So here, the big difference is now it says OpenCensus simple. That's kind of how you know that it's now running this new code. But it looks exactly the same. And if we go to Jaeger, we can see the exact same traces that we had before, right? The only difference is we don't have to manually forward those trace headers, but it looks kind of exactly the same. Okay, cool. So let's actually now use OpenCensus to look inside of our code. Now, this code doesn't really do anything, so I had to write a little bit more to make it more interesting. And what is more interesting than recursion? Recursion. No, I'm just kidding. So what we're going to do here is basically what I want to do is when I get that request, I'm going to calculate a random Fibonacci number using recursion. And then I'm going to basically see that number is odd or even, and then because that still wasn't slow enough, I'm going to sleep for a random amount of time. So the code looks pretty straightforward. Don't worry about this right now. So again, we're doing the same request to the upstream, and then we're doing this odd or even function where we're basically returning a promise and doing all this stuff. So calling Fibonacci. Great. So it's pretty simple code. Let's see how this kind of works. So if I do this, and we hit refresh here, of course we gotta wait for it to finish updating. Should take a few seconds. Come on, do it. This is why you don't run one replica, right? Running. Okay, cool. Come on. All right, there we go. Hopefully. Okay, cool. So now you're updated. We're creating this number, and then we're checking if it's odd or even. Yeah, very interesting code. Not really. Sometimes it's very small. Sometimes it's very big. It's randomly generated, right? Cool. So now we actually have some stuff that we can actually look into what's going on and why some things are slow and some things are fast. Before I do that, I just want to show you one thing. So this is the OpenCensus GitHub repository. So you can see Java, good amount of activity. You can see Go, good amount of activity. And then we go to Node.js, and that's pretty decent. You can see that it's kind of less mature. I think that's a good way of saying it. I'm pretty sure I'm the first person outside of the core team to actually use this. But if you're using Java or Go, there's a lot more robust support. So I would highly recommend taking a look at OpenCensus. Still alpha, but the node support is super, super, super new. In fact, so if I go, what I'm using right now is so we can see we have plugins for things like HTTP and HTTPS. So that means if you're using an HTTP or HTTPS server, so like Express, Happy, whatever, they all wrap around these, you automatically get this tracing and things like that. And you can export to a bunch of different backends, right? So I said we're supporting these standard backends, so Zipkin, Jaeger, things like that. Obviously, if you go, let's look at Python, for example. Scroll down to so framework integrations, so things like Django, Flask, etc. are, again, automatically traced. And MySQL, Postgres, things like that. So Python, again, has a little bit more support than Node, and Go probably has the best amount of support. And you can see here, all these things are automatically traced for you, right? Which is really, really cool because you don't have to, manually add tracing to your, MySQL connection, right? A lot of people have weird MySQL queries that might take forever. You don't know why. You don't know what's causing that. Automatically get tracing and stuff for that kind of stuff, which is really nice. And of course, there's a lot more exporters and things like that. So languages are still being worked on. It's a very alpha library. But the whole idea is that you just use OpenCensus and you get tracing and stats for all of the most common things that most people use for any backend, right? So you can basically get information from all of these services and export them to your exporter of choice, right? So this kind of creates that portability that I was talking about. Of course, so again, Node.js, very, very young compared to the other ones. They're all pretty young, but definitely check it out. So now that we have our odd or even Fibonacci thingamabob, how do we actually use OpenCensus to do anything? So the first thing, again, we do the exact same thing as before. We kind of just import our OpenCensus libraries. Now we're actually going to set up Jaeger, and we're going to set up Prometheus. Now, again, this kind of code right here is what you have to do different per provider. And so what I recommend most people do is just put this into a library and just import it. And then whenever you switch providers, you can just switch that library and everything else looks the same, right? So all we're doing here is kind of connecting to our Jaeger host, Jaeger port. We're getting that from environment variables. I'm putting the sampling rate to 100% just so I can do it for a demo. And then the same thing with Prometheus. It's the stats exporter, so Prometheus doesn't talk to a server. It just exposes a plain text page that is scraped. That's pretty straightforward. And then what I want to do here is set up my custom stats. So this is what me as an application developer really cares about, right? So I care about how many times this Fibonacci function was called. That is my business metric. My boss pays me on a number of Fibonacci function calls. So what I'm going to do is basically give it a tag. So in this tag, what I care about is the service name, right? So this is the same service running 3 times. What I really care about is which service is causing what. So I can put any arbitrary tags in here. And then this is an int64 because I'm just it's a count. Don't worry about why this number 1 or this number 0 are there. They're supposed to be enums, but they don't really work right now, so I just hard-coded it. And then we kind of register that stat. So now that we have the stat, we can actually use it in our app wherever we want. And now that we have this tracing, we can use it wherever we want. So let's see how it looks so really fast. So when we get our initial call, we'll actually get a parent span created for us automatically. This is because it's wrapping that HTTP provider, and so we're getting that parent span. And so now we can create child spans around our functions, right? So what I'm doing is I'm creating a child span called Fibonacci odd or even, and then running my odd or even function, and then I'm actually passing it in that child span. And then I'm calling end once that is done. Now, inside of our odd or even function, you can see that I'm calling 2 functions here, so sleep and then Fibonacci. And so here, I'm getting that parent span, and then I'm creating a child span again, and calling Fibonacci, wrapping it around, and then sleep, right? This is, again, a small bug. You shouldn't have to do this. You should, in this start child span, in theory, you should be able to pass in the parent span ID. Not, there's a bug open, don't worry about it. Like I said, super alpha right now. In fact, the docs for Prometheus, I just want to show you, again, just give you this an example. I did this 2 days ago, and so it was pretty difficult. I just want to share my pain with you. If you go to our packages, it's actually pretty nicely laid out. You can see all the different exporters. Prometheus is not a distributed tracing system, right? It's for stats and metrics. It's tracing, right? So yeah, this is all completely wrong. Please use it and give us open issues and things like that. That's how it gets better. People, don't know unless people use it in real life. So now we have both of this stuff. We're actually able to see these two sub-functions, right? Fibonacci and sleep, inside of this parent function, odd or even, which is actually inside of our HTTP handler, right? So again, if we go back to our page, everything kind of works the same. As an end user, I see no difference. But what we can do is go into Jaeger and let's find some new traces. Cool. Now we have 22 spans, a lot more than the 7 or 8 that we had before. So we go into this. Wow, that is way too zoomed in. That's way too zoomed out. Okay. Well, the screen is not going to let me show you everything in one screen. That's fine. So let's minimize everything. So we can see that our front end, if we go what happened to the front end, we can actually see that it is calling this Fibonacci odd or even. The Fibonacci calculation is taking a very long amount of time, and then the sleep. So we can actually, this is not supposed to be how it looks because I don't have enough space. But if you look at it on a normal monitor, it'll look a lot better. But you can actually see both the Istio spans that are caused with the network, as well as inside of our code, inside of our functions, right? Again, in one pane of glass. So they both work together because they're using the same B3 format. Everything kind of just ties in together really easily. So the last thing is stats. And I'm doing this a little bit incorrectly just for the sake of this demo. But in terms of OpenCensus, it's actually really easy to create custom stats. So we created that stat. Now how do we use it? I want to count every time I call Fibonacci. So all I have to do is do .record and then give it my value, right? So 1, so every time it'll just count up. And so in Prometheus, I can just go in and look at what that is. So OpenCensus. Let's look. Who can count the alphabet? Let me refresh. And so let me show you this real fast. So in our configuration, not in configuration, in our targets, we can see that we're basically scraping our 3 endpoints. This is not how you'd normally set up Prometheus, but just for the sake of this demo, this is how I did it. So we're getting these custom metrics called Fib metrics from our 3 different backends. And what we can do is look it up. There it is. So by default, it uses the OpenCensus prefix. You can change that to whatever you want. And let's look at what those numbers are. So you can get the counts. But the really cool thing is because it's a time series database, we can obviously see how it's going. You can see that our middleware had a lot. So for some reason, it got a lot of counts. And then eventually they kind of all normalize out. So we keep refreshing this. Prometheus is scraping on a 5-second interval, which is probably like more than fast enough for what we're doing. And we hit execute again. We can see that we got a spike because we had a bunch of DDoS attack. The Sandeep patented DDoS attack, which is hit refresh a bunch of times. So we get both custom stats, all the Istio stats, all put into this centralized Prometheus database. If you wanted to use another provider, super simple, just switch out the exporter. You don't have to change any of your actual code. So all of this, starting the spans and things like that, you don't have to change it when you switch to a different provider. And the whole point is Sure, it's fun to do these custom spans, but the whole point of OpenCensus is the built-in support for a bunch of common things like SQL, MongoDB, Redis, things like that. So you don't have to actually put, aside from your functions that that you're running in your code, any sort of calls to external services, things like that, should be automatically traced and automatically get metrics for you. That's the whole point of OpenCensus. So with that, let's go back to our slides. Yep. So it's kind of the end of this talk. It's kind of the shortened version because I didn't have to go through the beginning because most people here were at talk yesterday. Special thanks to Yana, who really helped with the Go side of things and the OpenCensus stuff. Obviously, I rewrote all of that in Node because Node is the superior language. Now everyone hates me, right? But I think the whole point is it doesn't matter what language you pick. Istio will support anything because it's just at the network level. OpenCensus, we really want to kind of give you the most out-of-the-box experience possible, regardless of what provider. Stackdriver will work great with OpenCensus. We want you to pay us for metrics and monitoring and things like that. But if you want to use someone else, please go for it. We want to just give you the best experience. Links, code is all up there. The documentation for the Prometheus integration is not up because it is super hacky right now, and I don't want anyone to even attempt to do what I did. But once it gets more, mature, I'll definitely update the README. But the code does work. So if you want to look at a actual working implementation of Prometheus on OpenCensus with Node.js, I'm pretty sure this might be the only place right now where you can see it actually working. But again, for other languages, a lot more mature support. Please let us know what you think, especially for OpenCensus. We're looking for contributors. If you're interested in distributed metrics and distributed stats, we would love your feedback and kind of understanding what your challenges are. Love your contributions and things like that. Istio, much more mature project, went 1.0. Still looking for feedback there, but definitely for OpenCensus, please contribute to the community. Again, if you have any questions, I would love to answer them. But aside from that, thank you all so much.